Hey, what's going on, folks? It's Mike here, and welcome back to my Deep Programming Language series. In today's lesson, we are going to revisit classes. And in the previous video, if you saw that, I did an introduction to classes, so we'll refresh a little bit on what a class is, but I ultimately want to answer this question of when should I use a struct versus a class. So let's go ahead and take a look here at the Deep Programming Language website. And again, let's go ahead to documentation, language reference, scroll down to classes here, and just get a little bit of a refresher here. In fact, let's go ahead to our text here. I've still got from our previous lesson, basically what a class is. So just highlighting some of these things. Again, a class is a way to create a new data type. It inherits from this base object called, well, object, similar to Java or how other languages do this, and that's where we're ultimately deriving a new type from. So classes have a lot to do with enabling inheritance. They allow us to do some cool things at runtime, again, like dynamic dispatch if we have different types of things. And ultimately, the important point is that classes are not equivalent to structs in the D language. So again, this is going to be more similar to like the C# model if you're coming from that language here. So ultimately, the question then becomes, when should I use a struct and when should I use a class here? So I think if I scroll through these table of contents here, I don't know if that's ultimately answered, and it's something that you kind of have to talk to folks about, or I guess you derive the conclusion that you want once you understand the technical mechanisms of these things. So the basic answer I'm going to give you is, if I scroll over here, when to choose which one is prefer structs unless you need inheritance. Okay, and that's going to be the general, try to do stuff with a struct first, and then if you need more power or some other, object-oriented feature or something, then you go to classes. Because again, what does a class require you to need here? So classes mean, and we covered this a little bit in the last video, but I'm just doing it again here and maybe a little bit more neatly for us. We need the garbage collector, which might be fine, and there are ways to avoid it, of course, because you're heap allocating everything. So let me just put over my head here the heap, and let's actually just move out of the way here. And it also means we have the dynamic, or let me just put it here, virtual. Okay, so we have virtual functions, or dynamic dispatch is used for most of our functions here. And again, that's totally fine to have these virtual functions here, but again, you just don't want to pay for them if you don't need them here. Okay, so let's go ahead and demonstrate with an example. I'll go ahead and pop back on the screen here, and we'll just bring up our terminal here. Let's go ahead and write just a simple little program here, maybe with some code examples here. And I'll just give you some examples of where to prefer a struct, for instance. So if I create a struct, like let's say I'm creating some data type here, like a vec3 here, x, y, and z. Probably don't need inheritance. I don't need to create something that is a type of vec3, right? This is all a vec is here. Okay, prefer struct in general. Why? And we'll list out some reasons here. Simpler, stack allocated, okay, is usually fast. Can always pass by pointer, can still, let me put this as a separate bullet point here, can still choose to heap allocate for lifetime or size of the object, but yeah, or rather let me say for the member functions are not virtual, so usually good for performance. Okay, and it also a contract to the client that they cannot derive a new type from this. Okay, a contract, or let's just say /design decision, that they can't do these things here. Okay, can't drive a new type, and this is how you want to use it. Okay, so that's why to prefer structs in general. And of course, you can still use structs in better C mode, which we covered in a few videos back here. Now, okay, that makes it sound like classes are really bad or something. So prefer class when, okay, and let's go ahead and list the reasons as well here. And let's go ahead and just create an example. Well, when I have some object that might be derivable. So let's just go ahead and go with a classic type here. Let's actually be a little bit more generic. Let's say I have like a widget or something. And what I mean by widget, that would be like a button, text label, you know, scroll bar, something like that. Okay, widget is usually the lingo for like some sort of thing that I can click on in like a graphical user interface. Okay, so reasons. I want flexibility to choose behavior at runtime. Okay. Because it's easy to choose between anything that is a type of a widget. So for example, let's do an example down here, right? I could just have widget and a dynamic array of them and call widgets, and then I could add in to widgets here, and I'll put this in the comments here. Let's say button widget, right? Can append anything to this list, right? So it's a really flexible way to do things. Now, of course, you can use like variants and other types and things that we've covered here to get this sort of behavior with structs as well. But, you know, sometimes this is just the easiest and sometimes the right thing to use here. We also get some features. We get some other nice concurrency features with classes. Things like, for instance, synchronized. So again, if you're familiar with that in Java, that could be a reason to prefer a class if you want to make this sort of thread safe in an easy way. So could just make things easy, okay? Which is usually not a bad answer to do things. But again, let's just go ahead and say, again, the real reason to use classes is for inheritance and, you know, dynamic dispatch of, you know, the correct virtual function. Okay. So again, it becomes very easy to use this thing here. Now, because we also get inheritance, we can also program to an interface, which is also nice, That's what I'll go ahead and say here. So in D, what we can do, let's go ahead and do some example here, right? So I could create a button that is a type of widget, right? And it inherits all of the widget things that I need to do here. Okay, so just giving you a little bit of a preview here. Like, let's say we have a position, I get those things here. And then in my constructor, I can call the other constructor of the widget and then do button construction things here. Okay, you know, and this is code that should compile. Oops, this is no superclass constructor, so we should just define one here. And let's just go ahead and say int, you know, x, int y, something like that here. X equals x, y equals y, something like that here. And then we could just put in, I don't know, maybe 5, 5, something like that here. Okay. So, you know, that's kind of nice and convenient here. Again, you know, for our sort of different behaviors and stuff, if we only want to override part of the behavior or part of the behavior part of the time, again, you've got the tools to do that here. So again, for some of the tasks where object-oriented is just a little bit cleaner to use and actually makes your code cleaner, use classes. But I really like just this designation of, you know, preferring structs wherever you can. So that was my note here, way above my head there. Because you get a little bit more flexibility on, like, if you want to stack allocate it, if you want to heap allocate it with a garbage collector in new. You can use malloc for your structs, for instance, so you get a little bit more choice with the allocator there. With class, you're really sort of going to go all in on the garbage collector, which is fine. Again, people complain about that, but to be honest, it makes writing programs pretty easy and memory saved, and you can write things that are like thread safe. So like, there's a lot of good pluses with this as well. It's not just a don't do this because it's not popular right now kind of thing. And that's the same way I feel about object-oriented programming as well, because you can do some really, really nice patterns here by having, again, you know, just like this little, you know, at runtime, I can choose the right type here by having a collection of things. And as I mentioned too, again, we can actually program things to an interface. So I'm going to show off these things, but just want to do like quickly here. We can say like interface iWidget interface, and then it must have a, like, I don't know, a render function or something like that. So let's go ahead and see how this works. So I'm going to go ahead and just pop this in here. And we're going to say our widget must program to the interface of iWidget. I'll run this. It's going to complain about it. So again, this is a nice contract for you if you have a long-lived project of saying, well, if I want a new type here, I need to implement the render function here. Okay, so we can come in here and say void render. Let's just give ourselves an empty function here, and then it'll work here, right? There's other nice things we could do. We can make these functions like final and stuff, and that gets rid of some of the virtual calls. So there's ways to get performance. But again, I just want to throw some of those things out there. We'll talk about them throughout, this series here. So again, make sure that you're either following along here or on YouTube or subscribed or whatever, so you can see all these lessons here, and we'll talk about optimizing these structures and again what an interface is and how to use multiple of them as we go along here. But anyways, I wanted to give you just kind of the quick summary of like when to prefer a struct versus class. I suspect this also applies in many other languages like C#. I think this argument's going to be similar. Although I haven't done too much C# recently, but again, they make this distinguishment that a struct is different than a class. If you're coming from C++, again, this is going to be new for you, and you should watch my previous video just so you can see how the semantics of structs, value types, and how they're different than classes. But classes, you got a lot more power with some overhead to manage that power, but that's sort of the deal here. So hopefully this gives you a reasonable reason or an example of when to use structs for simple types versus classes where you might want to have some nice inheritance capabilities and the runtime polymorphism. Alrighty, folks, so that's it. That's short and sweet. That should get you a lot of the way through making some of these, or at least understanding some of the different powers of structs versus classes. But we're going to spend the next few episodes here diving into how to use those features with classes, just so, again, you understand. So anyways, folks, thanks for your time and attention. Let me know if I missed something in the comments below. Look forward to reading your feedback otherwise, and I'll see you in the next one.